welcome back everyone. In the last episode we started creating a naive version of the network mapper, which is basically a tool that will discover servers and network nodes on a network and check the version of their services and stuff. I got a lot of comments about the last episode that I was only using a part of my screen, and I'm sorry for that. Unfortunately, it couldn't be solved. I usually record my videos exactly like that, but I crop away the rest of the screen, so I only use the bottom right corner of my screen, which is 1080p HT. But my Adobe account got locked, so I couldn't edit the video with anything else than the QuickTime player, and it didn't have any zoom and it didn't have any crop. So that's why I published it as is. Anyhow, I did publish it in 4K resolution, so you should be able to zoom in on your own without losing any quality at all. But today I will fix that, so no problems. Okay, so last time we only did the basics. We created a main function which takes an argument in the form of a TCP port number, a start IP address and an end IP address. And we will scan this range of IP addresses. If we omit this end IP address, we will start with a starting point and we'll go all the way to this DNetwork address. So we will not scan the multicast range. And if we omit both of these, so we only give the port, then we will read the IP addresses from the standard input instead. Okay, so let's see. Perhaps we should have a check for that as well. I'm not sure what will happen if we simply run this like this. Okay, both are 0. Alright, so if that is the case, then we want to read from standard input instead. So let's make it a little bit easy for us. Let's see, we have current, we have ending. Perhaps we should have a, let's see. Yeah, let's modify this generate function and check for the condition where current is 0 and ending is 0. So in this case we should read from the standard input instead. So let's create a buffer. I will make this an int 8 and we will call it buff, and let's read, how much should we do? Let's see, how big is an IP address at its maximum? So 123, 123, 123, 123. It's 4 times 3, which is 12, 3 dots, which is 15, and then we have the 0 at the end, so 16. Like so. And I do also want a 0 function, but let's, the 0 function I usually use in almost every project, so let's add that to the Birch utils library instead. So that can be our first function. It's very simple. We will have a void function which is called 0, and it takes 2 arguments. The first one is an int 8 pointer for let's see, we can call this the string, and then we have an int 16 for the size, And we also need to have a pointer like this, and we will set p equal to the string, so we will parse every character of this, or we will go through every character of this string. And it doesn't have to be a string, it can be any memory place actually. So p equals string from the beginning. We want to loop as long as two conditions are met. No, only one actually. So let's create an integer as well, and let's set this integer to 0 at the beginning. And as long as n is less than size, we want to increase n and we want to increase p. And at every iteration we simply want to set the current memory address to 0, which means we will zero out this entire thing, and then we return. Something like that. I do also want to include, and this will be in our library, so I will do like this, birchutils.h. But during development, I'm gonna comment that out, and I'm gonna grab it from the local directory instead, like so. And in our birchutils, what do we need here? We can put in, let's just add the stdio for now, and maybe string as well. And I also want to have, let's do, by the way, something like this. If not defined, birch utils. If not defined, birch utils. Let's do it like this instead. So if we have not included this file before, then we want to define birch utils. We want to include this stuff, and then we end this birch utils thing. This is so in case we include this birch utils.h from several places, it will only be read once. Because from the beginning this will not be defined, and then we define it and include all the stuff. And the next time this will already be defined, so nothing of this will be executed. And I also need my I also need my different integers. So let's define them here as well. It will be typedef, and we need an unsigned char, which is int8. We need an unsigned short int, which is int16. And we need an unsigned int, which is int32. And I have got a couple of questions why I define this myself when there is an include, which you can do. I think it's std int or something like that. The problem is they are not named int8, int16, etc. They are named something of the sort int 8t or something like that. And I really don't like underscores in function or variable names, so I rather define it myself the way I want it. Okie doke, so now we have this and this, and to make it a little bit easier during development again, we will add as an LD flag, I will simply, let's see, I will do something like this. Home, my username code, birch utils, birchutils.o. I will just include it like this during development. Like so. Alright, let's see if that compiles. So I will run make, and now we have both the O and the SO. So if I go back here, I should be able to use it. Does this compile at the moment? Int 8 buff, unused variable, cast from oh, this is wrong. I better fix that before I forget. Let's see. Yes, this is a string, so we need to call A2I in order to convert this to an integer. So let's see, if we save this now and compile, I will just see if it compiles. Make clean, jump down a little bit, clear, and make. Boom. Yes, it does. That's great. And if you're... oh, never mind. Alright, so let's continue this down. If we haven't specified a range, we want to read from the standard input each time. And I will make it pretty simple. I will just use the fgetS function. So let's do... first we zero it out. So we use our new function, 0 buff 16. Then we use fgetS, and the first argument is the buffer, I believe, and how much we want to read at maximum, 15, and then the file descriptor. And standard input is always open, we don't need to open it manually. Let's see that I got the order right, by the way, because it differs a little bit between similar functions. Read, for example, has the file descriptor in the beginning. Let's see, char s int size stream. Yeah, this is correct. Okay, so now we have an IP address read from the standard input. Perhaps we do, at least. Let's see. Let's create size variable, and we'll set size equal to the string length, or to the int string length of a char pointer casted call to buff. So let's see. There is a couple of possibilities now. It can contain a real IP address, and it will end in a new line, most probably. It can also contain only the new line, or perhaps nothing. Yeah, that's basically it. And what is the smallest possible valid IP address? It should be this, right? And then we have 1, 2, 3, 4, 5, 6, 7, and 8 if we have a new line as well. which means if size is less than 7, then we should return 0, and it should be an in address t of 0, because that means we have read the last IP address, or at least an invalid IP address, and then we are done. Anyhow, if we didn't read that, we want to decrease the size by 1 and use it as an index instead. So we want to check if, let's create a variable so it gets a little bit easier to understand. So let's create an int 8c. Let's make it a pointer. Let's do it like this instead. And let's point this pointer to the buffer plus size. So let's see if it contains, let's see, if we have something like ABC, it can't be since it's less than 7, but just as an example so I get the indexes right. And then we have this and we have this, which means the indices will be 0, 1, 2, and then 3, 4. So if we want to grab this new line, it will be index 3, and this size will be 1, 2, 3, 4, which means the index is size minus 1, and that is why we do minus 1 here. So this P now points to the possible new line, and if P is equal to a new line, or P is equal to this carriage return window style thing is, then we want to set P equal to 0. So we overwrite that new line with a 0, which means the buffer now contains the valid IP address. So now we basically only need to convert it into an in address T type and return it. And the easiest way to do that will simply be to do return inet address of buff, like so. Let's test this function. So instead of printing out ports and all of these stuff, I want to create a temporary inet address t variable. And I will set this to generate. And then let's print it. We need to print it as an integer at this point because we don't have a function to convert back. But that's okay. So let's see. Perhaps we can print it as a hex value instead. I think that would be a little bit easier to read when it comes to IP addresses. So maybe we can just, can we do int and then 10? But this is some kind of structure, isn't it? Well, let's see what happens if we do something like this. and I want to call this twice. Like so. Let's see, I'm not even sure if this compiles actually. No. Let's see. Implicit declaration of function 0. Yes, I need to include that. Okay. So that should be in our, let's see. I think I will create a small h file for this naive version as well as the common one. So let's do an nm naive.h. And what do we have inside of this thing? We have, okay, we can, let's move these two and put them here instead. And we want to include netmap.h, and in this one we want to include naive.h, like so. And inside of netmap we can include our temporary full path to home username code birch utils and birch utils.h. This ought to do it, I think. Let's see. Still some errors. Implicit declaration of function 0. Include netmap.h. Include this one. Is the path right? Yeah, if not defined, birch utils define birch utils. Okay, I need to add the function declaration. Inside of birchutils.h we need the void 0, and it takes an int 8 pointer and an int 16, like so. Pointer targets in passing argument 1 of if it has differed in signage. Right, I need to cast that. So let's see. You need to send this as a char pointer. And the rest is fine, I think. Point targets in passing different signs. Okay, same there. This is the downside by using your own variable types in C. But yeah, it is what it is. It has positive features as well. I like when the type system is expressive and things aren't just ints and stuff like that. It really is an IP address instead. Warning: cast from pointer to integer of different size. Alright, it is a 64-bit pointer. I'm too used to working with 32-bit processors, I think. So let's see. It's just our printf call that is bugging us. So let's do this unsigned long int and unsigned long int. Okay, didn't like that. Format %x expects argument to have unsigned int, but argument 2 has type long unsigned int. Should be lx perhaps. But it is a 32-bit thing we want, right? Maybe we are going the wrong way here. Let's remove this stuff. And if we do this, it will probably complain. But let's see how this in-address thing, does it have a man page perhaps? In-address T? Yes. In-address T. In-address T. Okay, it isn't a structure, it's just a simple integer. Okay, then I think this ought to work. Make clean, and we clear, and we do make, and it compiles. Perfect. What happens if we run this? Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. And this, nothing, but if we do something of the sort, echo 192.168.10.1, and we pipe this to Nmap naive 22. Okay, then it produces an IP address in hex, which looks right, I think. And it gives us a 0 the second time. Good. Let's see if we use the start and end thing instead. So let's create an IP address of 10.0.0.1 to 10.0.0.255. Yeah, the range seems to be working. And this should work even without this, right? Yeah. And if we were to do 255, 255, 255, 253, and 255, 255, 255, 254. This looks a little weird though. What about this? Perhaps it's because it's in the multicast range. Yeah, I don't think we should go any further than this. And let's do 0 instead. Okay. Yeah, it seems to work. Great, so now we have a functioning IP address generator, which reads from standard input and it reads from a range. And each time we call generate, it returns either the next IP address or it returns a 0, and then we're done. Pretty good. And this base code we can use in all our different versions, because this will basically be the same everywhere. So what do we need next? We need a way to connect to that IP address, right? And since this is our naive version, we will simply do a very simple function which does a standard blocking TCP connect. So let's create a function like that. We can call it, what should we call it? We can even, let's see, we can make a bool out of it. And let's call it TCP connect. And it needs an IP address to connect to. So in address T IP, and it needs a port number, and that can be an int16 port, something like that. And before I forget, let's add this to our naive. So this is a bool and it's called TCP connect. Takes an in address T and a int16, like so. And this is pretty standard stuff. We have done it in a couple of videos before, so I will not explain it very deeply. But if you want to know more about this part, you can always watch my video creating a TCP client and connecting a TCP server and a bunch of others. So what do we need? We need a structure, which is a sock address in, which will take care of all the settings. We'd also need a file descriptor, which I'll call S. And yeah, let's start there. So we initialize our socket by calling socket, and we give it an AFENet, which is a basic internet socket, and it should be a sock stream, which is TCP and 0. And let's check the return value of socket. I think it gives us a 0 or -1. -1 if it fails, which almost never happens. But let's assert that it does work. So S should be bigger than 0, basically. It should never be 0. Okay, so now we have initialized the socket. Now we need to fill out this sock address in structure. So the first is, let's see, syn family. And that should be AFINet. We also need to have a port, which is h-s of the int value of port. And h-s is a function which basically takes this port number and reverses the bits, so the most important bits are sent first. Network byte order, it is called. And then sock syn address s address should be equal to the IP. and then we do the actual connection. Perhaps we should have a structure for the return value, or a variable rather. So let's set ret equal to connect, and let's see, the first is the socket file descriptor, and then we need to cast the sock address and give it, and then we also need to have the size, let's see, the size of struct sock address, like so. And I think this should return 0 if it works, but let's double check. 0 is returned on error -1, yes. This time, however, I don't want to do an assert, because that socket fails, that should end the program, I think, because it's a very unusual error. But if the connect fails, that simply means that this port isn't opened or we can't connect to it, which means we should just carry on. So no assert here, because assert means that if this is not true, then the entire program exits. So let's do an if statement instead. If ret, so if ret is not 0, then we weren't unable to connect. And in that case we will just close down this stuff. We will close it down and we will return false. However, if it's okay, and I know the else statement is necessary here, but I like structure. In this case, we were able to connect. So what do we don't want to do then? We want to check the header of the port in case we have like a version or something like that here. And I think we should do this in its own function, right? So let's just call header and we send the S. Then we can close down S and we return true. Something like that. And it should never come to this part, but let's return false just so we have something at the end. Okay, quite simple. The most possible simple solution to this. And how should we do this header function? I'm thinking a little bit how we should log stuff. I think we will just log it to standard output at this point. Then I think we want to do something more of a log file or something like that. But at this point, this ought to be enough. Did we create the... Yes, we did. So let's make something for this as well. This should be an int8 pointer, and we call it header, and all it needs is an int for the socket file descriptor. So at this point we already have a valid connection, and all we need to do is check if there is data to be read on that socket. So let's create this int8 and we call it header, and we have an int s as an argument. And same here, basically we need to have an int 8 buff. Let's make it a little bit bigger. We want to zero out this buff entirely. And then we want to read from the S into a char version of the buff, and at maximum 255 characters. And like before, we also want to do an index. Let's call this index this time instead. So let I be equal to, or perhaps we can do this. Let I be equal to read, because read will return the number of bytes read. And let's say if I is less than maybe we should include the IP address, by the way. So in address TIP, and same here, in address T, and when we call this function we give it the IP as well, because that will make the logging a little bit easier. So let's see, if I is less than 1, in that case we'll just print f the IP address on its own, I think. Yeah, let's do that. And as we don't have a function yet to convert this into a real IP, so let's do the hexadecimal until we have created that function. So basically like we did before, and we give it the IP, like so. However, if I is reading something, it has a value greater than 0, then we want to turn it into an index. Let's see, let's do 2 here instead, by the way. It will make stuff a little bit easier for us. And why would we read 1 byte? That's not really interesting, right? So let's see, let's take this -1 and let's make a pointer here as well. I like dealing with pointers. It makes the code easier to read, I think. So P will be equal to the buff plus I, and if P is equal to a new line, or if P is equal to this window style carriage return, P will be equal to 0. Then we will simply print f the IP address and the string. So let's see, we have the IP and we have the buffer, like so. And when this is done, yeah, we should return the data. Okay, let's make this static then, and we'll still be printing it here, I think, at least for now, and then we will return the buffer. like so. I think that will be good enough. Okay, unused variable TMP. And no other errors. That's pretty amazing. Sometimes it works out of the box. We don't know if it works though, but let's hope. So make clean, jump down a bit, clear, make, and run this thing. Let's see, we have something left, right? Because we haven't really called our connect function yet. So we need to have some kind of main loop. Or maybe just a loop right here. So let's see. Let's create a variable after all. Let's do in address TIP and while, and we do IP is equal to generate. As long as this is not 0, we wish to run TCP connect against the IP and the port. Did I give the correct order? TCP connect IP port. And when this returns 0, we simply exit. We don't even need this. Okay, does it still compile? Make clean, jump down a little bit, do make. Yes, it does. Okay, so let's try it against something we know is open. If we connect to localhost at port 18, then we should get that string. So let's see. Let's echo that IP address. And let's pipe it to our program at port 18. Huh, it works. So this is the IP, this is the header. And what if we don't have a header? Do we have any other open ports? Quite a few. Well, let's connect to the IRC server because that is not giving any output until we send stuff. So that would be a good example, I think. So let's try it against 6667. And I think in this case, if everything goes as planned, it should report the IP address, which means the port is open. But it will probably take quite a while for it before it times out. So while this is running, let's go into this code and let's try it against the port which will not be open. So let's take something like 12344. In this case, it will probably try to connect. Either it will wait until it times out, or it will receive a connection refused and terminate pretty instantly. I think it should be the second option in this case. Yes, terminates instantly. However, if we were to connect to something which is firewalled, and what should it be? I think we can try something like my web server, because it's behind the firewall and shouldn't be able to be reached from here, I think. I need to resolve it. Let's see, drbirch.com. We echo this IP, and then we run our program against, what port should we do? Let's try 23. Okay, now it's trying to connect. And this, okay, we did get actually the error message when it disconnected us. But in other case, if it were to just disconnect us, we should just get this part. So our program works. It would be kind of nice if we could try this program against some real network, or at least a simulated network with different IP addresses and different services running with different versions and stuff. So we tested against something which is more like the real life internet. We could port scan like a range of servers somewhere, but it's no good thing to do that, because we will probably get abuse mails and stuff. So let me think a little about this. If you have any ideas, please put it in the comments, and I might have an idea how to create a simple simulated network. I'll talk more about that in the next episode. By the way, if you like this series, please like and subscribe. There will be more episodes coming up, and the next one we will perhaps create that simulated network, but we will also create the version 2 of this scanner, which will be much faster, because we will be using non-blocking sockets instead of blocking sockets. I will also try a different way of using the blocking sockets we're using right now, but by altering the timeouts, so it will also be faster. And I will also try to do some tests, so we can see how many seconds it takes to scan our test network with the different versions and stuff like that. And I also intend to do a lot of more cybersecurity stuff in the future, not only, but more than before. Alright, thank you for today, and thanks for watching. Take care, everyone.